name is Chris. Chris, I'm sorry. I'm Brian.
How long have you been here?
That would get us even, right? I'm messing with you. You're not messing with my name. Fair.
So I've been
Nice
here
to meet
for
you, though. Thanks for coming to the talk.
just last spring.
Stop it.
Okay.
Are we using blue mic or orange mic?
No, my undergrad was in mechanical engineering,
Okay,
so I might not know them. Yeah.
Brian, you can turn nice to meet you. Nice to meet you.
Doesn't ring a bell. Yeah. Yes.
Hello, everyone. We will be starting the. Okay, we will be starting the talk shortly. Thank you for coming. Happy New Year. This is our first talk of 2026. Before I introduce Brian, I just wanted to let you know, because of spring break and us collaborating with the Texas Science Festival, some of our dates for talks have switched, but if you follow us on any of your social media or go to the website, scienceunderthestars.org, I believe, you will find the most updated schedule for the forthcoming semester. Okay, without any further ado, I would like to welcome Brian Stokes, who will be talking to us about changing birds in a changing Texas.
Hi, thank you guys for coming out. Yeah, so my name's Brian. We're going to talk about birds in Texas and how they're changing. Let's get into it. I'll give you guys a quick overview of where the talk's going to go. First, we're going to talk about birds in Texas, why they're cool, why Texas is a great state for birds, some of the things that are going on in Texas that aren't so cool and not so great for birds, and we're going to talk about what's happening to our birds in Texas. So that's the route we're going to go. Real quick first, I'll give you guys some background on me. I am from North Florida in a town called Jacksonville. I grew up in an area called the St. Johns River. This is a really old steel engraving plate by a guy named Harry Finn from his book Picturesque America. He was selecting the most beautiful areas in the post-Civil War America to show off, and he showed off this area right in my backyard. It's not exactly as birdie as that, but it was a pretty birdie place to grow up, and that's kind of where I started getting interested in birds as a kid. I then went to the University of Florida, got a degree doing stuff with wildlife, so I got a lot of hands-on experience working with animals, including birds. I worked with turkeys for a while and got to pretend to kind of be a country boy, which was fun. And then after undergrad, I had some jobs in places like Oregon, working with endangered species like marbled murrelets, and then working in New Hampshire with winter flocking species like this very pretty little and puffed up redpoll. It's a classic kind of northern bird species in North America. And nowadays, I'm at the University of Texas getting my PhD. I work with green jays, which are a local, really pretty species in South Texas. And when I'm not doing birding stuff and I'm not doing school stuff, I sometimes like to root on longhorns with my little baby. And so, yeah, that's essentially me. So a big reason why I was so excited to come to Texas for my PhD is because Texas is a great state for birds. So about 671 bird species have been recorded in Texas by observers, which is a lot of birds. Okay, that's about 5 to 6% of the birds you can find across the entire globe. Now that number is a little bit inflated. It includes what we would call things like vagrants, which are birds that kind of just pop up and aren't super common or are here for just a little bit of time. So in reality, the number of birds that actually live and hang out in Texas and spend important parts of their life cycle here is maybe around like 500 or so, give or take, depending on the year. Now, this painting on the right is by a guy named Billy Hassel. He's a cool Texas artist that does a lot of paintings of birds. This is a place called Powderhorn Ranch, which is on the Gulf Coast, and just shows off some of the diversity of bird species we have, as well as some other stuff. So lots of great birds to see in the state. And in Travis County, we get about 430 species that have been reported. Again, this is a really high number. Realistically, year over year, you're going to see a little bit less than that. But really a great space, or a great place to live to see birds. So I have a question for you guys. I think we have some smart audience members. Why do you guys think there's so many bird species in Texas?
Maybe because Texas has migration paths.
Texas has migration paths. That was a great idea, Trisha. What else? I saw a hand. Yeah.
We have a lot of different habitats.
A lot of different habitats. Okay, you guys are taking most of my talk. What about you?
Really big and there's a lot of
Texas is really big. It has a lot of biomes. Okay, those are a lot of the big points. So, like we said, Texas is very big. This is the Texans, map of the United States. I'm not from Texas, so I get to poke fun at you guys. But this map has kind of a grain of truth in it. Texas takes up a really large space compared to other states, and it also stretches into a lot of different ecosystems. You have the northern plains that Texas reaches into. You have the southern tropics near Mexico that Texas reaches into. We get eastern species from the east side of Texas in the eastern piney woods, and we get a bunch of western species out near El Paso. So we're in a very lucky location, and we have a very large state to see lots of birds. Now, a great example of this and why this placement and location within the United States gets a lot of birds is through our resident jay species. So on the left, we have a woodhouse scrub jay. This is kind of our western jay species that comes from the western edge of the state and into the hill country. We have our southern, our tropical green jay that reaches into South Texas and is kind of up near areas like San Antonio nowadays. And then we have our eastern forest blue jay, who covers most of the eastern U.S., very familiar in Austin and San Antonio. We see these all over the place. And so right in the middle of Texas, lots of species pairs and trios of closely related birds and other animals meet and intersect in their ranges. And that's because the state is just reaching into so many different habitat types. Now, Texas has, of course, the lower Rio Grande Valley. This is one of my favorite places in the state. And it gets us a lot of really interesting tropical bird species that just barely poke into the state and aren't found in other places in the United States. This includes birds like our green kingfisher, green parakeet, Altamira oriole, and hook-billed kite. And some of these are more common than others, but these are really cool, widely distributed tropical species that just barely poke their geographic distributions into the state. And so all these tropical bird species are really important for our state and actually have a really valuable economic impact in South Texas. And so a 2011 study found that non-game related wildlife and nature tourism in South Texas accounted for about $500 million of economic production economic activity in the region. There's even a Rio Grande Valley birding festival in fall, and people come from all over the country and really all over the world to go see birds in this area of the state. I really think it's an underappreciated area of our state that we're super, super lucky to have in our backyard, just to see some really neat animals. Now, someone said something about all the habitat types, and that's where we're going to go next. For resident bird species, we have a huge mosaic of habitat types in Texas to choose from. So this map shows what is defined as level 3 ecoregions, so kind of relatively fine scale types of habitat within the state. And in the southeast, we have areas like these Gulf coastal plains and eastern piney woods. In central Texas, we have coastal oak savannas and blackland prairies. North towards Dallas, there's the cross timbers. Towards the panhandle, we have the tablelands and high plains. In far west Texas, we have Chihuahuan high desert. And people think of this as areas like Big Bend or Terralinga, really, really out there, tumbleweeds, rough terrain. Closer to home, we have the Edwards Plateau, and in southern Texas, we have one of my favorite areas, the Tamaulipan thorn scrub, also called Tamaulipan mesquital. And so few regions in America can compete with the habitat diversity offered in Texas. And this level of diversity allows for a lot of different places and a lot of different habitats for birds to live. And now, my friend Tricia also said something about migration, right? And that's a very good point. So these are maps of 4 different migration flyways. And these are kind of just general ideas to think about where birds are migrating in North America. And so we have on the top left the Pacific Flyway and on the top right the Atlantic Flyway. And sometimes birds from these poke into Texas, but they're not really common. But we have really, really high impact from both the Central Flyway and the Mississippi Flyway. So the Central Flyway, birds fly through Mexico, up through Texas and Arizona and New Mexico, and then all the way wherever they're going to go hang out for the summer. And then the Mississippi Flyway, birds cross from either the Yucatan or the Caribbean across the Gulf of Mexico and hit our shore, usually in areas like Corpus Christi or Galveston. And you can see huge numbers of birds in spring that are migrating through Texas. And so just to give you a number, about 1 in every 3 birds migrating through the United States during spring passes through the state of Texas. So really punching above our weight for how many birds we're getting in the state. So we're here to talk about anthropogenic change in Texas. So I didn't call the talk anthropogenic change because it's a bit of a word salad. But anthropogenic change is just kind of a fancy word scientists use to describe human-made change. It comes from the word Anthropos, which is a Greek word for human being, and genic, which I guess is just a science word meaning producing. So change produced by humans. And that's what we're going to start talking about, is anthropogenic change. Now this map is a pretty good visuals for the areas of Texas where we see lots and lots of human impact. And we can just see it by the map of light on the state. So we see really big cities like Houston, Dallas, Fort Worth. We can see Austin, San Antonio. We can even see the Eagle Rock Shale, which is where there's a bunch of oil and gas production in the state. So not as many people living there, but there's some interesting environmental impacts in this area just south of San Antonio. Now, I do think it is important to note that anthropogenic change in Texas is not a super new phenomenon. There have been people living in Texas for a very, very long time. Thousands and thousands of years even. This is a photo of a thing called the White Shaman mural, which is found along the Pecos River, and it's believed to show pretty clear evidence of human movement throughout the state a few thousand years ago, including trade and cultural exchange between different groups in central Texas. So these people, of course, have impacts on their environment. They used resources in the natural landscape, and they modified the environment to suit their needs. One great example is the use of prescribed fire by some native groups in plains habitats to change browsing and vegetative structure to benefit the hunting of bison and buffalo. So these people were really, really smart about taking advantage of their environment, and they had, their level of impact, although significantly less than what we would see around contemporary Texans' impact on the environment. There are a lot more people who know much more about this topic than I do, so I'm not going to really talk about long-term anthropogenic change today. There's lots of resources you can look into if that's interesting to you. We're just going to talk about really recent anthropogenic change, okay? So what are some of the anthropogenic changes affecting birds in Texas? We're going to break these into just a couple examples. I'm not going to go through every possible change. I just want to give you guys some high-level vignettes to talk about some of the interesting things going on in Texas and how some birds are responding. So I'm going to break these into three general groups. There's changes in climate and habitat, and I think you guys can see this. Okay, cool. Changes in climate and habitat, forms of environmental pollution, and then shifts in biotic communities. So the animals are living beings that birds are interacting with. And again, this does not include all the issues that birds and other animals are facing. I won't even have time to get into things like disease introductions from game or livestock reservoirs, ground and surface water usage in the state, which is gaining ground as a real issue, and then impacts of things like invasive plant species. So again, this is not every single problem facing birds. There's a lot more. And if you have questions about that, I'm happy to talk. So let's get into it. First off, we can talk about changes in temperature through climate change. So this is the temperature trend over about the last 50 years in Texas. And you can see the whole state is red, which indicates that it's getting warmer. So not every county in Texas is warming at the same rate, but generally speaking, most of Texas over the last 50 years has gotten much hotter than it previously was. And this tracks global scale temperature trends. So you can see this black line is the global warming temperature, so the difference from what would be considered the normal temperature. So it kind of squiggles up and down. Some years get hotter, some years don't get as hotter. But broadly, since about the 1920s, when really the onset of the Industrial Revolution had gotten going, we can see that atmospheric CO2, shown as this blue line, has increased. And about at the same time, the temperature has gone up. So there's pretty solid evidence that those are linked. I'm not going to go super into depth on that because people know a fair amount about that. But we really know that as carbon increases and other greenhouse gases increase in Earth's atmosphere, temperature will continue to increase globally. Now, climate change doesn't just affect temperature, it affects precipitation and rainfall patterns. So in the short term, Texas has recently been in a drought, and not the whole state, but a fair amount of the state has been receiving a lot less rainfall than what it's used to. And again, these droughts are not super long-term trends, but over the last few years we are in a drought, and there are some projections that expect that we'll continue to have a lot of drought conditions over the next 100 years in the face of climate change. And you can project through some fancy modeling people do what the future change in precipitation is going to look like. So this is the projected change in precipitation for about 2050 using a pretty middle-of-the-road climate scenario. So climate change isn't going to get way worse than what's projected, and it's not going to get much better than what's projected. This is kind of what we expect the general trend to be. And broadly speaking, we think Texas is going to get a little bit drier, but not too much drier, whereas some other areas in the United States will get a little bit wetter, but not too much wetter. And there's some disagreements in models over exactly how significant these changes will be, exactly what parts of the states are going to get wetter and what parts are going to get drier. But for the most part, we should see some relatively drier years in Texas in the future. And the combination of increasing temperatures in the state and changes in rainfall can lead to a pretty broad pattern called tropicalization. And so we've seen this in a few states in the south of the United States, whereby species from the tropics move northward towards more temperate areas, or what was formerly more temperate areas. So these areas become warmer and have less intense cold in the winter. Species that are used to warmer weather can move northward in response to that. And this is most consistently observed in exothermic species. So exothermic species are the species that cannot produce their own body heat. So think lizards, think butterflies, think little buggies, things that don't produce body heats like mammals and birds do. This is also true for plants and a few other organisms. And so basically, these organisms have their biology really closely linked to the outside temperature around them. They have a lot of energy and a lot of survival constraints that have to do with how the outside air feels. So right now, it's a little chilly. We're doing okay for the most part. I appreciate you guys sticking it out. We have jackets, our bodies can produce heat. But if I was a lizard, I would not be feeling so good, and I would be a little less active than I am today. But birds are, of course, endothermic species, meaning they produce their own heat. And generally speaking, birds are really hot. Oh, that's from a different slideshow, sorry. I meant to say, birds have a fairly high body temperature when compared to other small endotherms. Sorry about that. So here's two major groups of birds shown in red. And this is what we call their normothermic body temperature. And that's just generally the basic operating temperatures we're at. So humans have a normothermic body temperature of about 97 degrees. Birds vary based on what species it is and their size. And you can see non-passerines, which are generally a bit larger than passerines, are a little bit cooler. Passerines are a little bit warmer. Across all birds, this ends up being about between 97 degrees to 110 degrees Fahrenheit. And so maintaining this temperature in cold conditions can take a lot of energy for birds, especially for our small-bodied passerine birds that have a lot more surface area than larger-bodied birds do. So they have a lot more of their skin being exposed to the cold air temperatures. So they need to use energy to stay at their normal, happy body temperature, which we call their thermoneutral zone. On the right side is a I'm going to show a graph in a second. It's going to look crazy. It's a really over-complex graph, okay? And this is showing birds' thermoneutral zone. And it's a plot for a bunch of different bird species. And I don't want you guys to get too in the weeds on this, because it's a little too busy to get into. But basically, this graph shows that birds near the equator, found here on the 0 latitude on the x-axis, generally speaking, have a more narrow and generally higher thermoneutral zone than birds on the far right and left edges that are from more temperate zones. So in other words, tropical birds like outside to be really warm and not change too much, whereas temperate birds can do okay with more variation and like it a little cooler, but also really like a lot of hots and a lot of colds compared to the tropical bird species. And this generally makes sense. The tropics are a lot hotter and they don't experience the seasonal temperature variation that we experience in temperate regions, right? And so an area like South Texas might continue to warm. We might experience less temperature variability, possibly allowing the region to fall within the thermoneutral zone of a fair number of tropically dispersed bird species that are currently south of our border. And so we see this, what might happen as areas change in their temperature through species like the Couch's kingbird. So this is a tropically distributed species found in South Texas. And if we use a model to show the increase of 2 degrees Celsius globally, this is a model done by a group called Audubon, we can see that we can expect Couch's kingbird to be able to inhabit a new area that they currently are not in, this blue area on the map near San Antonio. I'll have my shadow point towards it. So right now, you're very, very unlikely to find Couch's kingbirds there. But if this area of Texas continues to warm, potentially less extreme cold in the winters, or other factors will allow the birds to establish or colonize this area fairly well. So another major issue in Texas are the effects of habitat loss and degradation. And these are a little tricky to discuss in Texas because we don't have a really certain baseline for what many environments in a pre-colonial Texas would have looked like. Texas also has really low levels of public land ownership, with about 95% state being in private hands. So we have a state government which generally avoids super strong legislation regarding how private landowners can manage their land. And so our state's landscape is really, really reliant on the actions and decision-making of private landowners. And there's been a lot of investment by groups like Texas Parks and Wildlife to equip private landowners to make choices that are beneficial to habitats and beneficial to things like bird species in the last few years. And so a lot of times when I think of habitat loss, I visualize what we would consider tropical deforestation, where these massive areas of lands are just completely cut down, huge things of trees, and they're transitioned to uses like extraction of wood products or use for palm oil production or cattle ranching, and the land completely changes its usage. And this occasionally happens in Texas. We have a type of land use called, new model homes. And in Texas, this would be one of the primary drivers of contemporary habitat loss, is transition from former habitat into low-density housing developments. And these, of course, offer a fairly low amount of ecosystem services for birds and other animals. Sometimes people are really good about having nice gardens and having bird feeders that help birds, but generally speaking, they're much worse for our native fauna and flora than actual native habitat would have been. But Texas kind of makes up for this in a way by using a process called working lands. This is kind of a term I was not familiar with in Florida, but it's used a lot in Texas. And so we classify a lot of land into working lands, which some people would consider the next best thing to just completely native habitat types, which we would kind of consider, your ideal situation for a lot of land use. Just be whatever it was before people got there. And within the current bounds of land ownership pressures in Texas, this is probably a pretty good model for what we can do. So a properly managed timberland can still act as a reasonable quality habitat for native fauna that likes natural timberland. It's has some of the vegetative structure, might have some of the plants underneath, and you can imagine something like a cattle ranch might potentially have some of the ecological mirroring that a natural habitat like a buffalo's rangeland would have. Now, of course, both these land uses are not going to be as good as the natural habitat. They've been shown to both have less diversity of animals, birds, plants that would be in the natural proxy. But if it's that or a parking lot, I'll take this every time. This is pretty good. And so, they shouldn't be considered as equally good as truly native land cover. But this is one of the options people in Texas have to conserve their lands. And we can, with a combination of changes in both land cover and warming temperatures, this can change to extreme changes in where birds are living. And so sometimes this might just be general decreases in where we find species. So we don't find them as much. That's a change in where a bird's living. But sometimes we find an increase in where these birds are living, like our Couch's kingbird model. And so this is through a process called range expansion. And so in Texas, these expansions are generally poleward or northward, while sometimes these poleward expansions can be linked to climate change, this isn't always the case. Sometimes it's more closely linked to land use changes. And so a good example of that where it's not linked to climate change is through our friend, the crested caracara. So this is a really neat bird that we actually see in Austin every once in a while. There's a nesting pair on Mopac just north of 35 you can sometimes see flying around. And so in the last 15 years or so, we can see on the left side of the screen, there's a map of where these birds are found, where the darker purple color represents more crested caracaras, and the lighter purple color would represent less, and then no purple color represents pretty much no caracaras. And we can see over the last 15 or so years, they've increased the areas in Texas where they're living and moved a bit north. And you can now, again, reasonably find these nesting around Austin and San Antonio, and some areas around Houston as well. And so it seems that this species has expanded its range based on changes in habitat use. And so as more habitats have become open, this bird really likes open habitats. It likes hunting for things in the ground or finding carrion, so dead animals. It does really well as habitat has changed from sometimes native brush or agricultural uses into sort of these open ranchlands or rangelands in some parts of the states. They can also utilize human-made structures for nesting, so it's possible that in a highly anthropogenic landscape, they've really benefited this population. That's true, especially for the ones we see in urban areas, like the one I mentioned that's up Mopac on 35. I think it's nesting in like a light pole or something. I haven't found its exact spot, but one day I will. The Great Cascade also shows a similar pattern, where a combination of land use change and warming temperatures has likely allowed the bird to increase its distribution northward in Texas over the past 15 years. So now you can find this bird pretty commonly all the way between Austin and Dallas and spread out into a fair amount of other areas. Now some species are more closely linked to climate. So this is a clay-colored thrush, and this was actually not found in Texas until about the 1940s, but has become relatively common in the lower Rio Grande Valley. And this species does seem to have its northward expansion limited by cold winter temperatures. And this is, again, likely for a number of tropical bird species. Like I mentioned, how some of them have lower thermoregulatory capabilities than these temperate bird species. So there are just some birds that can't handle the cold. Oh, and here's its expansion. Sorry about that. So they haven't become super common, but they're a little more common north of their original range. And then the species I work on is occurring with green jays. So green jays, we can see in the map on the right-hand side that their historical range is delineated by this black dotted line. And you wouldn't really find them north of the Rio Grande Valley too often. Every once in a while, there were birds that we would consider vagrants that go a little farther north than where the majority of the species is. For the most part, most of the green jays that were breeding in Texas were right around the south of Texas. And over time, over about the last 60 or so years, they've expanded their range northward up to an area between about Del Rio to San Antonio to Victoria, which is kind of on the Gulf Coast of Texas, just north of Corpus Christi. And so these birds have likely expanded their range as a result of a number of factors. And so a decrease in winter cold temperatures almost certainly would benefit a tropical species like the green jay. These birds also take advantage of supplemental food and water resources found on a bunch of the private properties around South Texas. And I wanted to point this species out because I don't think range expansion should be seen as a purely good thing. It might seem nice because birds are living in new places and we think that's great, but it has a lot of interesting impacts. So when birds expand their ranges, they enter into established avian communities. So you have a place where there's a group of birds that have lived and they've assembled together for a long time. If you have a new bird species, that changes the interaction between birds within that community. It might change the food resource availability, it might change nesting availability, and cause lots of issues for what we would consider native or local species. These range expansions can also introduce diseases or pests, and sometimes they have really unexpected results. I and my advisor, Dr. Kidd, have been studying the species for a few years. Back in 2023, we found what we consider a pretty novel outcome of range expansion, which was a hybrid between green jays and blue jays. So we found just one of this individual just outside of San Antonio with the help of a citizen scientist named Donna, and we performed genetic testing on the hybrid, which is pictured in the center here. And then, of course, a blue jays on the left, a green jays on the right, to show that it actually was a hybrid between these two species. And we knew these species were beginning to come into contact with each other. We had been tracking the green jays' range expansion for a while, and so we knew, sooner or later these birds were going to be hanging out with one another and interacting in different ways. But we really did not expect these birds to be able to hybridize. They're not very closely related species by bird standards. They're about 11 million years diverged, which in evolutionary time is pretty long for a group like birds to be able to hybridize. A lot of birds do hybridize, but those distances in evolutionary time are like 1 to 3 to 4 billion years is more reasonable. And so I really just want to point this out because I think this finding was important because as other species come into contact through range expansion with distantly related relative species, we have to wonder if novel contact will affect natural breeding dynamics, will produce hybrids, and will just produce general unexpected outcomes. And so that's one of the things that I thought was really interesting is what outcomes we haven't really thought about happening, even though we expect range expansion to continue for a lot of species in South Texas. Will there be new dynamics at play we haven't really imagined or thought possible? And so this is one of the major issues of range expansion is that we just don't exactly know what's going to happen if it continues. So we'll continue on to some other forms of anthropogenic change. We'll get into light pollution. Now, I have this picture here that shows light pollution, but we also luckily are just outside for this talk. So if you look up, okay, everyone's looked it up, great. We do see some stars. Austin's not the brightest city in Texas, but we do see a lot less stars than we would see in native areas. And birds do utilize stars, and birds do utilize nighttime. So changes in light pollution actually affect birds a lot. So one of the ways that they affect that light pollution affects birds is during migration. So cities like Houston, shown on the left, use a lot of lights that are very bright. If you've ever driven around Austin or Houston or Dallas at night, they are bright, bright places. And there's actually been a lot of efforts to curb the use of lights in these cities during migration because so many birds end up flying into the cities, becoming disoriented by the lights on these tall buildings, and then actually crashing into windows and having relatively large-scale mortality events. And this has been studied in a bunch of cities across America. Chicago is a major, major issue because for some reason it's a point where a lot of birds come to before spreading out across the Great Lakes. But Houston, Dallas, Austin and San Antonio have similar issues where during migration, we see a huge spike in the number of birds crashing into windows and dying. And so we don't like dead birds. That's a pretty negative impact on species. And we can see, this is going to be a little figure showing how we see where birds are migrating. So we actually track bird migration through radar. So these little white dots are actually radar stations. The same thing the Weather Channel uses. These can track any particulate in the air, and sometimes they can track really big particulates, like birds. Birds are just really big raindrops, essentially. And on a map, this looks like these kind of really big clouds expanding from these radar stations as birds take off during their migratory flight. So this figure shows sometime in mid-October, and at nighttime, that's when birds actually do the majority of their migration. So as it comes to about midnight, right there, you can see that there's a lot more birds in flight than there are during the daytime. And you can put this together into pretty complex models. There's a bunch of people at Colorado State and with USGS that do really cool work showing how birds migrate through the United States. And so this is a figure from an app they have called Birdcast, which shows where and when birds are migrating in the United States. And they can do this day by day by looking at these weather radar stations. And so this is a screen recording I did of September 25th or September 24th of last year. And this was a huge, huge night for migration. So you're going to see the areas that are in white or orange are where lots and lots of birds are flying. And so they're all flying towards South America from areas in the northern United States. And you're going to see the arrows kind of showing the general direction where they're moving. We can just watch this really quick. It's kind of neat to show where they're going through. So again, you can see Texas is a huge hotspot. And that red line is the onset of nightfall. And as soon as it's night, birds start really flying. And a huge number of birds fly through Texas. You can see on the eastern edge of Texas would be birds that are in the Mississippi flyway going over the Gulf of Mexico, and then birds on the western portion of Texas, or what we consider the central flyway, flying through areas like Mexico over the mainland itself. And so look how many birds are ending up flying through areas like Houston, like San Antonio, like Dallas. And so these lights can have huge, huge impacts on birds and just the instant mortality events for a lot of species. Now, light also has other impacts on birds. It quite literally makes it brighter, and expands the day length. So artificial light makes days longer for resident birds. You can see for example, this figure up top, areas with bright landscapes, such as an urban park, which is going to be this kind of orange-colored curve, shows the level of vocalization birds are using. So the higher the peak is, the more loud birds are. And then the x-axis shows the time of day. So in the morning, birds are really active, and in the evening, birds are really active, right before the sun goes down. And you can see that in this urban area, where it's really bright, morning activities start about 18 minutes earlier than the onset of daytime, and evening activities about 32 minutes later than birds of the same species in non-urban landscapes. So this study was just comparing birds like for like in urban and non-urban areas, and showing that the urban birds have really long days. Which, in some ways you might think that's nice. I like having a long day. That's pretty useful. I can do a bunch of stuff. But for birds, it's actually a huge amount of extra stress. Sleep is very important for wild animals to, recover, do whatever stuff the inside of your body does. We have other scientists here who know a lot about that I actually don't know much about. But not sleeping and getting less sleep is really, really bad for some of these birds. And we can see that this relationship is actually linear. So on these bottom two graphs, the left side is the morning time, the right side is the evening time. You can see that as light pollution increases, the beginning of their singing actually gets earlier, just as a linear relationship. And on the right side, the singing and the activity stops later as light gets brighter. So it's just a purely linear relationship. The brighter your area is, the longer your day is. So it's very useful. We should be pushing our local governments to do a little less street lights and stuff. We don't need so much. Cars have lights. But anyways, this is an additional stress for birds. It's not good for them. So we'll move on to another form of pollution. This is sound pollution. And so this is a map of showing sound pollution in the United States. And it's going to be pretty similar to our light pollution map, but it's got a couple other areas that are interesting. You'll see the impact of roads really heavily and the impact of flight pathways. And, again, we have a great example of this pollution right now. Let's listen. Generally relatively loud, but not extremely. Sound pollution is generally going to be low frequency sound. So it's not going to be these really high frequency sounds. It's not as high pitched as my voice. You can just hear kind of low noises. Again, here's a good example. There's a car going by. That's going to be a lower frequency sound. Because birds are highly vocal communicators, they have to find ways to work around the influence of noise pollution on their communications. So one good example of this is through our friend the song sparrow. This is a beautiful bird we get to see in Texas every once in a while, especially this time of year you can see them. And what they've done is, as song sparrows in urban areas have had their songs filtered by low frequency anthropogenic noise, they've actually increased the frequency of their songs. So this would be areas with really, really loud anthropogenic noise on the x-axis, and then this side of the x-axis would be areas that are relatively quiet, not as much anthropogenic noise. And so again, that anthropogenic noise is generally a lower frequency sound below about 1,000 hertz. And so to compensate for that, these song sparrows in really loud environments have actually increased the pitch at which they sing to be better heard by their other song sparrow friends. So they sing at a higher pitch so they can reach past all the anthropogenic noise. Now, another way to be heard through anthropogenic noise is shown through our buddy, the white-crowned sparrow. This is a nice bird you can also see in Texas. And this would be what we would consider their historical sound. So we call it sonogram or a spectrogram. And this is just kind of a way to visualize what their song looks like. So on the y-axis, we have the frequency of their song. So higher up would be a high-pitched noise, lower down would be a low-pitched noise. And then on the x-axis, as we go from left to right, is moving forward in time. So as you go in time, they make a sound that goes a whistle, a buzz, and then these really complex notes like a, and then trill notes. And so this is what their song looked like and sounded like in 1969. And researchers were realizing that their sound was kind of changing over time. And so in 2005 and 2020, researchers went back out and resampled to see what their song had sounded like at that time. And over time, what these birds have done is they've actually made their song across a huge number of individuals much less complex. And so now one of the dominant songs you hear from white-crowned sparrows is this much more simple song where it still has the same general structure as their song would have in 1969, where there's a whistle sound and a buzz sound. But now, instead of having a really high number of complex notes and trill notes, they just said, let's do like 4 or 5. That's all we gotta do to get through. So they're getting through this anthropogenic noise by being a lot more simple with their song to make sure their conspecifics are hearing them better, or it's something happening while they're learning the songs, because birds learn their songs from other birds. So if they're hearing a really complex sound and parts of it are getting kind of blanked out by loud noises, it's possible they're just not learning the complete song. So over time, again, these songs have gotten much less complex, and this is true in a couple different bird species. This is just the only example I'm going to show today. Another form of pollution is just kind of what we classically think of as pollution. Different types of chemical pollutants from different sources. And so it's sort of on a similar vibe would be DDT. So DDT is a classic story in bird pollution. And DDT was actually an insect spray, so it had a very clear use in agricultural settings, and sometimes in not so agricultural settings, where they just go around town and just spray the whole thing with DDT. And it was a really effective insecticide, so it's very popular, very heavily used in the United States and a bunch of other areas. But DDT had a really negative side effect, and so DDT would slowly enter water sources just by leaching through or by accident. It was not really purposely poured into water sources. And through a process called bioaccumulation, the amount of DDT in the water would go into the phytoplankton, the zooplankton would eat the phytoplankton, the bay anchovy would eat the zooplankton, and they'd increase the amount of DDT in their bodies. And DDT has really, really negative effect on birds and was actually making bird eggs much, much weaker. So this example shows snowy egret eggs. These would have been one of the victims of DDT. One of the most famous victims of DDT was bald eagles. So this is the graph showing bald eagle populations over time. And so I show this example because this type of anthropogenic change is actually relatively easy to curb if we make very clear steps to fix it. And so you can see back in the mid-1900s, the bald eagle population, and this is at a site in Virginia near the Chesapeake Bay, which is a great area to see bald eagles nowadays. It was incredibly, incredibly low. There were, less than 50 bald eagles, probably less than 10 in most areas. But at one point in 1972, the EPA decided, why don't we just ban DDT? It seems to be bad for these birds. Lo and behold, very quickly the bald eagle population, as well as a bunch of other bird species, were able to very quickly rebound. And nowadays, bald eagles are reasonably common. So this is a really clear success story of how we can fix a lot of the anthropogenic changes that humans are causing in our environment. We'll move on to some other quick effects of anthropogenic change. So really quick, we're going to talk about changes in insect populations. This is what we would call the windshield phenomenon. And so the classic kind of story is back when you were a kid going on road trips, you'd see a lot of, your windshield would be covered in insects after a long drive. And nowadays, we don't really get as many, not nearly as many as what I remember when I was a kid driving around. And this has been empirically shown to be true, that there are decreases in insect populations in a bunch of areas across the globe. So this figure shows the decrease in daily insect biomass collected across nature reserves in rural Germany over the course of a 26-year study. So these points are different sites where they did trapping. And so insect biomass and total populations have decreased across all the study sites in this place with an average of 75%. So there are 75% less insect biomass than there was 26 years ago. That's a lot less food for birds, like our good friend, the vermilion flycatcher, who almost exclusively eats birds, or our resident golden cheek warbler, who is highly, highly dependent on feeding its chicks insects during the breeding season. So this is a general negative consequence for birds, and we don't actually have a great idea of how bad this could end up being for birds. It's kind of a newer area of study. People are trying to figure out what is going to happen to native species in birds as there are just simply less things to eat in their environment. Are there ways to compensate? And we think some species probably could, but a lot of species just have to eat insects, and if there's less insects, there's probably less of that species. I think I'm a little tight on time, so I'm gonna skip through my next one and just do a really quick touch on one of the other really, factors that people don't realize, and that would be feral cats. I love cats. They're very cute animals, and I like my friends' pet cats. But unfortunately, feral cats that are outside kill a huge number of birds annually. Globally, it's estimated they kill between 1.3 to 4 billion birds, and they kill between 6 to 22 billion mammals annually. So these things are very effective killing machines. And if you ever had a cat and they've brought you a very nice, what some people will call a gift of a dead bird, that might be, nice of that cat, but it's not very nice for our native birds that we would like to value and take care of and be good stewards for. And so across the board, these anthropogenic changes ultimately result in variable winners and losers. It's thought that for the most part, disturbance-tolerant, generalist, and intelligent species like our local great-tailed grackle, northern mockingbird, and green jay might be able to, win the changes in landscape and changes in climate that we're seeing, at least in the short term. So some of them will be able to expand their ranges or move into different habitat types. But there's a lot of species that we would consider specialists. So they have really specific ideas and really specific constraints for what habitats and food types they can use. So these would be things like our local, again, golden cheek warbler has really, really specific habitat uses that it has to have. It has to have very specific matrix of different types of trees in the environment, and it can't really handle much change from that. They're a little, you can call them picky. The scientific word for that is specialists. Or snowy plover, who have really specific habitat constraints. But I do think there's hope. Like the changes with DDT in the United States, it's totally possible for government agencies and individuals to change our behaviors at a scale large enough to prioritize the well-being of native habitats and species. And I'll leave you guys with this. Whooping cranes, shown here in another painting by the wonderful Billy Hassel. These are a beautiful bird you can see in Aransas National Wildlife Refuge right here on the Texas Gulf Coast. And they actually faced extinction with about 20 individuals left back in the 1940s. But through collaboration, through a number of very, very committed conservationist individuals and private nonprofit groups, as well as some cooperation from begrudging federal and state level stakeholders, their population has steadily increased, and there's now about 600 whooping cranes in the US. And so this is a huge success story. And I think it is really possible to reverse a lot of the negative consequences that being a human has on the environment. We can change the way we act, we can change the way we consume goods, we can change, maybe at certain times. The government can do things differently than it currently does to prioritize conservation and protection of our native species and natural resources. And so I think there's hope. We can make Texas and we can make the world a better place that takes better care of the animals and plants and insects and things that live here. So thank you guys for listening. Can we do questions? Any questions? Okay, yeah, we're gonna do questions. This way? Oh. Does anyone have questions?
I have a mic, but I'm happy to run it out. So if you put your hands up, I will bring you a mic.
You are welcome to ask. I may not have a good answer.
How do you get data that goes back to like 1960s or even earlier?
That's a great question. So a lot of the data we use at large scale is citizen science data. So people use apps like eBird to record where and when they're seeing birds. But there's a couple other sources that are great. So there are what we consider natural history sources. So there's a few books from people that were naturalists and would record species distribution. So there's a really good book called, I think it's called like The Bird Life of Texas, by a guy who was a professor at UT from 1972. So I refer back to that a lot. But on a large scale, there's other programs like there's banding. So banding is when we catch birds and we put a little leg band on them. And that gives us really good data about where birds are and where they're moving to. And there's been banding efforts in the United States back to early 1900s. There's other efforts too, like the Christmas bird count is something that I think Audubon leads up. That's been going for a really long time. There's the Breeding Bird Survey, which is a pretty large scale continental-wide survey effort that looks at where and when birds are breeding, and is done by really, really solid birders. So we have good data at specific spots that goes really far back. So there's all sorts of data sources. Yeah.
Got it. Thank you.
Yeah.
Is it hard to like get people to buy that like range expansion is happening in Texas, because even though they're like they live in a different place and they used to be, they're still like native to Texas, so people would be like, oh, it's a native bird, it's okay that it's in Texas. But I don't know, is that something that you like range expansion for people?
That's a really interesting thought. I don't know if I've had a lot of pushback. I do think in general I'm sympathetic to people that are doubtful of these changes because they happen over really long time scales. So it kind of is hard to remember what 50 years ago was like. I mean, I'm not 50, but you talk to people. There's plenty of people across America who we are living in a hotter climate than we were when they were kids, and they still don't believe that that's happening. So, I don't agree with why they're seeing that or the conclusions they come to, but I'm to some extent sympathetic with that. I think with birds, it's great because you just see new birds. And we really like this green jay study. And one of the reasons we worked on this is because it's a green bird. If that's the first green bird to show up in your yard or your ranch, you're kind of going to notice that. Maybe there's a bunch of little brown birds that are changing their ranges. And you're like, oh, that might be a sparrow. That might be something else. And you don't really know what it is. But if a green bird shows up on your ranch for the first time, you're going to realize it and say, that's a really cool, reasonably sized green bird. And so when we talk to ranch owners, and we do a lot of trapping on ranches, people are pretty good about being like, I think I first saw this in like 2015 or something, or or they'll relate it to like, oh, yeah, this was when Obama was president. I saw this bird for the first time. And a couple people give me weird memories like that. So yeah, I don't know. We'll see what happens if range expansion continues in different areas. I think the more challenging thing is linking it to what's the cause and being really clear about what's causal with it is pretty difficult science and modeling to do. So yeah. I don't know where the mic is. Oh, okay, I guess you have the mic. Yeah.
So I know you talked about the hybridization. I can't speak, sorry. From the blue and the green jays, and I know that's also been happening with like the titmice in Austin with the question and gray ones. Is this becoming more common due to humans, or is it just that we're just noticing it now, or is it just more common due to other factors?
That's a good question. Yeah, so you mentioned the hybridization between tufted titmice and black-crested mice. We think that's been going on for a while. There's two zones where those are happening. There's one in Oklahoma and there's one in Texas. And I forget the exact details, but I think the one in Oklahoma is older and has to do with changes in land cover over time or something. Although I might have that detail backwards, and maybe the Texas one is older. My advisor, Tim, would know. What do you think, Tim? Was the Oklahoma one older or the Texas one older?
This hybrid zone for titmice in this region is maybe a few thousand years, like a few hundred years for Oklahoma.
Okay, so yeah, the Oklahoma one might have to do with changes in landscape in the area. The green jay, blue jay hybrid we saw, we would clearly link to changes in landscape or climate in the state where it has caused range expansion to an area where green jays were not living. Blue jays are in San Antonio where way back in historical Texas they would not have lived, and so both those species have expanded as a result of human actions or accidental actions in the state, allowing them to have contact and produce hybrids. And it's totally possible other species will continue to do this as other species expand their ranges. The good thing is a lot more people look at birds, and there's people that have cameras and stuff and post stuff on like Facebook. So it's easier to pick that up, especially in areas like the U.S. We don't know what's going on so well in areas with less access to the resources we have in Texas, less money to pay for like genomic sequencing like we were able to. So it's possible it's an issue in a bunch of other places, and this is there's some bias to the results we're seeing based on the things that we have here. So yeah.
First of all, a couple of comments and a question. This was one of the best talks of this program, and I don't know how long have we been going? 15 years? 20? Yeah. Thank you. Couple of comments. On March the 8th, 2025, I saw a pair of caracaras. I photographed them in the dead oak tree over here in Lake Austin Center.
Yeah.
And then they were messing around on the roof over there. So from what you're saying they were probably looking for a place to nest and moved over to Mopac.
Well, I've seen that Mopac pair for a while. So I think there's probably a few groups of caracaras in Austin. So I don't know. The one in Mopac I've seen for like 4 or 5 years now, and it's north of 35 Mopac, somewhere within like a few blocks of that. But I never was able to find where they're at because there's a bunch of those like TxDOT structures around it that are really big, and so you can't.
Why wouldn't they pick our place, right? I just don't know why.
I don't know. Yeah, I mean they like open habitat, and we see them in other areas in South Texas, like nesting on human structures, like telephone poles, or I've seen them. There's a really cool one we see nesting out near Galveston that's on this like old solar cell thing for a cell phone tower, and it's like you can see the tricks real close. So I mean, the structure seems to be helpful because it mimics some potential natural habitat structure that would be like trees in larger rangeland areas or prairies. But yeah, I don't know. I could imagine we'll see them more often, especially with supplemental like dead animals.
The second comment has to do with cats.
Yeah.
So in '91, we got a female deer in here. She had 2 male fawns, and then she played whoopee with her male fawn, and then we had 62 deer by 2002. And then a coyote population builds up eating baby deer. And then they cleaned out all the feral cats. We used to have feral cats all over this place.
Wow. Okay.
And the cats simply disappeared. And then we started seeing rusty lizards.
Oh, interesting.
Again.
Yeah.
So the cats were really cleaning out our lizard population.
Yeah,
so
I mean,
you just see that.
It's pretty hard to like have an idea of how much impact they have. It is true that they have more of an impact in islands. So areas like Hawaii or the Caribbean have really, really big issues with feral cats. And I mean, I've seen videos where they're just essentially slaughtering seabirds that are these really rare species. And in a place like Texas, it's not as big. So island birds sometimes will evolve to not have a lot of fear of mammals. There's some islands that just don't have a lot of mammals. This is things like areas like New Zealand. Hawaii doesn't, I don't think, had any native mammals, although I might be wrong. But anyways, a lot of birds in these island habitats just evolved to not be fearful of predatory mammals. And so it really causes big issues. And that's true for both mammals, birds, herps, really I mean, cats are really amazing hunters. We just don't want them to hunt our native animals.
I do have a question, and that is,
yeah.
Do the green jays do what blue jays do in terms of predation on other birds' nests?
Yes,
So that could be one of your negative consequences of this thing.
Yeah, that's a really great point. So they're saying, so some corvids will eat the eggs of other birds because it's a really good, high energy, dense food source. And blue jays are known to do this. There's a good paper, I forget who it's by, but it might have been a UT student, showing that blue jays had been nest predators of golden cheek warblers. And so blue jays historically did not have a lot of range overlap with golden cheek warblers, and were able to expand a little bit more into the hill country and started eating every once in a while golden cheek warbler eggs, which is not great because they're a threatened or endangered species. It's likely green jays do the same. I can't remember from the literature, but I would guess, they're going to eat anything they can get. Like I'll watch them eat just whatever random bugs they can find or little critters. So yeah. We have a question from Trisha. Oh, is there a mic back there?
Yes, I will run the mic to Trisha.
Yeah, you got the question.
Could there potentially be a whole rainbow of jays
A whole rainbow. I don't know. We have some good jay colors here. We have three different blue jays. Every once in a while you get Stellar's jays in El Paso, and then we have wood-owl scrub jay, and we have blue jays. We have green jays, and they have a lot of yellow on them. There are brown jays very, very occasionally in South Texas. These are pretty rare, and they're a really funky, big-bodied jay, and they hang out on the river. I have not seen them, but I would like to. Is that all of our jay species, Tim? Any more in Texas? I don't think so. I don't think there's any red jay species, but in the tropics, there's really, really cool jay diversity. I mean, there's the curl-crested jays, really neat. It's got this like insane feather protrusion on its head. If you ever go down south of Mexico, you'll see lots and lots of good jay species. There's a bunch of white jays as well. There's some white ones, and there's a purplish back jay that's nice. There's some good colors. I don't know if red. It'd be hard to find a red one. Yeah. Okay, Tricia.
I have like 4 things to say.
Okay. Let's do it.
One of them is that why is it like you guys know chickadees?
Chickadees?
Like the black-capped and Carolina chickadees look exactly the same.
Yeah.
But they are different species. Which is kind of weird because all dogs are one species and they look completely different. So why is that?
That is a very good question, and I am not the best to answer this. But black-capped chickadees and Carolina chickadees are considered different species because they produce offspring within their own species for the most part. So they don't often produce offspring to the others, although every once in a while you can have a hybrid between a black-capped chickadee and a Carolina chickadee. And this happens in an area around Pennsylvania. And they have an area where the two birds, their ranges come into contact, okay? And there's been a really cool study by this guy, Scott Taylor, and it's shown that over about the last 25 to 30 years, the hybrid zone where these two species meet has moved north as the climate in the area has warmed. And it moves literally about 1 kilometer north per year. So it's moving poleward like we see in a lot of range expansions. And it seems that has to do something with release from freezing temperatures. So some birds are really good at handling the cold, and some birds like our Carolina chickadee aren't as good. But as that area gets less cold in the winter, they get to go a little bit farther north than they used to. So,
okay.
Yeah.
Well, I have more things to say.
Okay, let's hear them.
So, you know those hybrid birds?
I do.
I've heard something like birds that are hybrid can't produce like offspring. Is that true?
That's a good question. So some birds can that are hybrids and some birds can't. So there's hybrids between tufted titmice and black-crested titmice, and that happens around Texas. And the hybrids can actually produce offspring, but some animals that are hybrids can't produce offspring. So have you heard of a mule?
Yes.
Okay, so a mule is a hybrid between a horse and a donkey. And they have different chromosome numbers. The horses do and the donkeys do. And so when they need to produce their gametes, which you use to make baby horse or baby mules, the mules end up with a really funky number of chromosomes. So animals really like to have an even number of chromosomes, and when they end up with an odd number, like the mule does, it gives them a lot of trouble when they go to produce gametes. People that know this stuff better than me, correct me if I'm wrong. Is that right? Okay, close enough. Yeah. So a lot of hybrids can't, but some hybrids, if they have the same number of chromosomes, potentially can. But there's what we would call barriers to them mating. So sometimes there's behavioral barriers. Maybe you're a blue jay and you see a blue jay green jay hybrid and you think, ooh, I don't think he's very cute, and you don't want to go on a date with him. He's not a blue jay. You like blue jays mostly. Or maybe he doesn't sing a very good song and you're like, I don't really like this one. So there's a lot of barriers that would produce them from making offspring. Does that make sense?
Okay.
Cool.
2 more things.
Yeah, let's do it.
One, this screen doesn't tell us.
Oh, it doesn't. Oh, that's really bad. Okay, that's a good point. That could be a big issue for some of these birds if it doesn't have legs. That's a good point. You should send an email to this artist. He's local.
Last thing is that Can I share the fun fact?
Oh, yes. Trisha's going to give us a fun fact. I asked her to do this.
Yeah.
You ready?
Yeah.
Okay, you got this.
So, a killdeer is a type of bird. And a killdeer, when it finds some threat, then it pretends to have a broken wing. And when it has a broken wing, then it just like it tries to lure the threat away from its nest.
Uh-huh.
And then when it thinks that the threat is far enough, then it just flies away.
Yeah, that's awesome. Can you do, I do this for my killdeer dance. I do this one. But you do that? I think they do drag their wing.
Yeah, like I don't have.
That's really good. That's actually very good. This is very biologically accurate. Nice job, Trisha. Thank you. Okay, cool.
Unfortunately, we are out of time for questions. Maybe we'll take one more question.
You guys are just come talk to me after.
Yes, thank you, Brian.
Okay, well, I actually have like 3 questions. So
Wow. Okay, amazing. Sure.
This is gonna go a little
Are we
longer.
allowed to do 3?
we do 3 quick questions.
Okay, 3 quick questions.
So my first question is, with these species with expanding ranges, like, could that be contributing to like the bug populations, and could they be considered invasive at some point?
Yes. Yeah, you know, when we call something invasive, a lot of times what people are thinking of are species that are like introduced by humans. So this is common in things like zebra mussels, where they're from different places and boats bring them and drop them off, and they have kind of a starter population, they spread out. The same is true of a bunch of invasive species in South Florida, like Burmese pythons and a bunch of other ones. So yes, sort of. It's not really what we traditionally think of as invasive species, but yes, it is invading or colonizing a new area. Yeah.
Because like climate change is caused by humans, so
Yeah.
in a roundabout way, we could be the ones introducing them to this new environment.
Yeah, yeah. It's kind of all just semantics. You know?
And then my second question was, what effects can we see on other native species because these birds are depleting?
Yeah, that's a great question. So birds have a lot of ecosystem services. So, you know, birds serve as food for other animals. If you see coyotes, they'll eat dead birds or dead turkeys, things like that. Birds do really great uses, like they clean our streets of roadkill. Birds are insect control, so things like swifts and flycatchers really help with general insect populations. Yeah, there's a bunch of different ecosystem services birds have. Birds are pollinators. Hummingbirds pollinate lots of beautiful flowers that are native to the area. And so loss of hummingbirds or changes in where hummingbirds are distributed will change the pollination of all these things. There's a bunch of other ecosystem services, but those are some examples.
I forgot my third question.
That's okay.
Thank you. Thank you. Okay, thank you very much for coming. Brian, if it's okay, people can come up to you after after we give him one last round of applause. Our next talk for this semester will be on February 19th. It's the evolution of evolution. So hopefully we'll see you all there. Thank you. Good night.